Better safe than sorry.
So, first one's pretty straight up. You got 50 milliliters of 0.14 molar acetic acid, 50 milliliters of sodium acetate. Is that a buffered solution? Yes, okay. Now, this is not a titration. Nothing like that. Now, when you get to number 2, you're going to add 20 grams of acetic acid and 20 grams of sodium acetate to form 2 liters of a solution. Listen to me. Listen to me. Listen to me. The first thing you got to do is convert those grams of acetic acid and grams of sodium acetate into moles. When you do that, okay, you've got 20.0 and 20.0. Those have 3 significant digits. When you convert those grams into moles, do not round that value too much. You want to keep at least 3, I'd even do 4, significant digits when you get to those moles. Okay? Do not round them or you are screwed going forward.
Can we keep the whole number?
Huh?
Can we keep the whole number?
You just need your calculator?
Yeah.
Yeah, that's fine. So, you want to determine the initial pH. Now, on B, I want to make sure everybody's cool with B. I said I want the net equation for the reaction that occurs when sodium hydroxide is added to the solution. I want the net ionic, so I want to make sure everybody's cool with what's going to happen. So on B, I'm going to add sodium hydroxide to this solution that has the acid in it and the anion in it. Are you going to, because I want the net ionic, am I going to worry about the sodium?
Yeah.
No?
No.
Because the sodium is just going to be a spectator ion. It's just the sodium is not going to be involved in anything. Okay? So I'm not going to worry about the sodium. Now, here's the question. What is that hydroxide ion going to react with? The anion or the acid?
Acid.
So on B, here's what I want for that net ionic. So you're going to have acetic acid, which is HC2H3O2. I want to scoop that out. Plus hydroxides. And then out of that, what are you going to get?
Water.
And the anion. Now, the reason that I keep the acetic acid as this, okay, is because it's a weak acid. This is how this thing is existing, okay? It is existing in the molecular form. Now, if I had said I'm going to add potassium hydroxide to hydrochloric acid, hydrochloric acid is a strong acid. So if you write the net ionic for a reaction with hydroxides and it's a strong acid, your net ionic is just your hydroniums plus your hydroxide yielding water. So when you write the net ionic involving hydroxides, if the acid is a weak acid, you write the whole molecule because that's how that's existing. If it's existing as a strong acid, your net ionic is just hydroniums plus hydroxide yielding water. Okay? All right. You're on your own. Be free.
Wait, so on